Hi guys, welcome to my channel Electrical for You. In this video, I'll be explaining you how to design an electrical system. As you know, it's a specialized job and nowadays it is mandatory to know electrical designing for an electrical engineer. The designing process is a bit a lengthy one. I have decided to divide it into 11 modules and each module will be uploaded regularly. So let's start our introduction to the video. As you can see in the screen, there are 11 steps I have mentioned. Step 1 is voltage selection. It is mandatory to choose the feeding voltage and is dependent on the project load requirement. We be selecting the voltage based on the total load requirement and the maximum demand for the system. I'll be explaining this on the later session of the video. The next module will be transformer selection and followed by HV cable selection, generator selection, LV cable selection, instrument transformer and meter selection, generator protection and transformer selection, capacitor bank selection, MSB busbar design, fault calculation and earthing design, preparation of electrical scheme. That's the final step. In electrical design, we have to take a few elements into our consideration in the downstream of the supply. They are from the transformer and diesel generator, the supply goes to MSB or MDB. From the MSB, the supply goes to SSB or SMDB. And from there, the supply goes to the final DB, FDB. And finally, the supply goes to the electrical points, which is outlets like switches, sockets, lights, other machineries, electrical appliances, etc. Now let's discuss on step 1 voltage selection. To select the voltage, first we have to calculate the total load requirement for the project in kVA. As we know, all the electrical appliances and machines except transformers are rated either in HP or in kW. Transformers are rated in kVA only. Let me explain the design with an example. In the example, we have to consider a few elements like the loads, demand factor, transformer efficiency, percentage impedance of the transformer, fault MVA, soil resistivity, and the type of starters used for the motors, etc. Here, let the given demand factor is 2, transformer efficiency shall be 80 percentage impedance of the transformer shall be 5 percentage, and the fault MVA, let's consider it as 250 MVA, soil resistivity as 100 ohm meter. Consider all the motor starters shall be star delta, and future load shall be considered as 10% of the total connected load. Let us assume a project has a requirement of 200 HP motor, one number, 2 numbers of 100 HP motor, 4 numbers of 50 HP motor, 4 numbers of 25 HP motor, 6 numbers of 10 HP motor, 10 numbers of 5 HP motor, and it has a lighting load of 10 kW. You can see in the screen all the loads are listed in the chart. In the third column shows the number of machines that we are using, and the fourth column shows the capacity of the machine in HP, the power in HP, and the fifth column shows the power in kW, and the sixth column shows the power in kVA, and the seventh column shows the total load in kVA. To obtain the load in kVA, let us consider the power factor as 0.9. Multiply the same with kW, then you will get the load in kVA. Here, if you sum up the loads in column number 7, including the lighting load, you will get the total connected load as 682.51 kVA. The next step is to find out the maximum demand. The equation is total connected load divided by diversity factor. Now, here rises a question. What is maximum demand? It is nothing but the maximum load that the consumer use at a particular period of time. For example, if we have 50 light points at our residence, we will not use 50 light points altogether even at the peak hours. Instead, we use maximum 20 to 25 light points at a particular time. That's why in projects where there is a bulk load requirement, we consider only the maximum demand. As I said before, here we consider the diversity factor as 2. So the maximum demand will be 50% of the total connected load. That is, here the maximum demand is 682.51 kVA divided by 2. That is 341.25 kVA. Now we have the total connected load and maximum demand. Now let us see how we can select voltage based on this. The given chart shows the selection of voltage based on maximum connected load and maximum contract demand. It is taken from the supply code 2014. As per the chart, up to 5 kW, we can use single phase 240 volt, and up to 100 kVA, we can use 3 phase 415 volt. And if the maximum demand is between 100 kVA and 3000 kVA, we'll go for 11 kV, which means that we have to install the transformer if the load lies between 100 kVA and 3000 kVA. As our maximum demand is 341.25 kVA, we have to choose 11 kV as our incoming supply, and we have to select a transformer for our project. For more details and examples, kindly visit my blog on electrical design. The link is given in the description. Your feedback and subscription would help me to prepare more videos like this. I'll come with the next video on transformer selection. Till then, take care. Bye-bye.